formation of dipeptides. So if we look at a recap on the amino acid structure from last lesson, so in the middle you have the central carbon, which is bonded to a hydrogen and a variable group called the R group, and then that joins to a carboxyl group. The central carbon joins to a carboxyl group, which is a C double bond O OH or Cu group. And then the other side of the central carbon, you've got the amine group, which is NH2. So you've got your central carbon, your carboxyl group, your amine group, a H, and the R group, which is different between each amino acid. So as some examples of R groups, alanine has the R group CH3, whereas glycine has the R group H. So what you could do if you have a biochemistry model kit is you could make up the amino acids alanine and glycine, and then you could try and eventually join them together via a condensation reaction, taking the water molecule away. So if we just look at the structure of proteins, the primary structure, or the polypeptide, polypeptides are composed of amino acids bonded to each other like beads on a string, and the bond that holds them together is called a peptide bond. Now it's very important you know that in amino acids, the bond between the amino acids during condensation that's formed is a peptide bond. So the peptide bond is formed by a loss of water, so it's a condensation reaction to form polypeptides. So if we now just look at how a dipeptide is formed, which is two, because di means two amino acids. So dipeptide means two amino acids joined together. So an OH is taken off the carboxyl group, and a H is taken off the amine group of another amino acid, and the H2O is taken away or released because it's a condensation reaction. So the OH from the carboxyl group and the H from the amine group is taken away to form a water molecule, and that is released from the reaction. And what you get is a peptide bond, which is formed between the C and the N. So that there is the peptide bond. So you take the OH from the carboxyl group, the H from the amine group, and that forms a peptide bond. And it is a condensation reaction because water is released or taken away. So if you did have a biochemistry model kit and you made an alanine and glycine before, what you could now do is join them together by a condensation reaction to form a dipeptide. So you could take the OH off the carboxyl group of alanine and the H off the amine group of glycine, stick them together, and you should have a bond between the C and the N, which is the peptide bond. So the OH from the carboxyl group of one amino acid, the H from the amine group of another amino acid, that forms a water molecule, and there is a peptide bond formed between the C and the H and the N. Now if you wanted to split this dipeptide back into its single amino acids, you would do the opposite. You would add water by hydrolysis. And what would happen in that case is one of the H's from water would go back to the amine group, the OH would go back to the carboxyl group, and you would split it, because it's lysis, which means splitting, using water hydrolysis. You would split that dipeptide back into its individual amino acids. So, polypeptides are long chains of amino acids. Monomers are amino acids. A dipeptide is formed when two amino acids join together. A polypeptide is more than two amino acids joined. And proteins can be made up of more than one polypeptide. So your monomers are amino acids, dipeptide is two amino acids joined, polypeptide is lots of amino acids joined, and proteins can be made up of more than one polypeptide chain.